Good day, students. Today I want to discuss a topic titled Gravitational Force Between Two Masses. Gravitational forces exist between one body in a galaxy and the other, and between stars, between moons. The gravitational force exists between them, and it is the gravitational force that holds those bodies together that didn't allow them to skip away. And the man named Sir Isaac Newton was the first person to propose the relationship that exists between gravitational force, the masses, and also the distance between them from the center of each masses. The distance is taken from the center of each masses, and Sir Isaac Newton proposed the law of gravitational force of attraction, which is also known as the inverse square law. He said that the force of attraction which exists between the two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. And he proposed the law, and also is named as the inverse square law. Let's see, and you can see it here. Gravitational forces act between all masses and hold together planets, stars, and galaxies. Each mass has a gravitational field around it. It was Sir Isaac Newton who first proposed the relationship between the gravitational force F between the two masses m1, m2, and a distance r between these masses. He proposed his famous law of universal gravitation, which he states as follows. Every particle in the universe attracts every other particles with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This force acts along the line joining the center of the two particles. Newton's law of universal gravitation is an example of an inverse square law. You can see inverse square is square this is the inverse square law is F is directly proportional to m1 m2 over r squared. We said inverse square law because of this r squared. Is that okay? Now F equals, when you remove the positive constant, F equals g m1 m2 over r squared, where m1 m2 are the masses of the two particles, r is the distance between them. G is equal to gravitational constant equals 6.67 times 10 to the power minus 11 Newton meter square per kilogram squared. Gravitational attraction keeps the moon in its orbit around the earth, and the earth in its orbit around the sun. Gravitational force of attraction keeps them together. Okay, now let's see example. Two masses m1 equals m2 equals 5 kilogram are placed so that their centers are 50 centimeter converted to meter divided by 100, that's 0.5 meters apart. What is the magnitude of the gravitational force? And you have your G to be equal 6.67 times 10 to the power minus 11 Newton meter squared per kilogram squared. Now use the formula equal to G m1 m2 over r squared. What's our G? 6.67 times 10 to the power minus 11 times 5 times 5 divided by 0.5 squared. Now when you multiply that, you have 1.6675 times 10 to the power minus 9 divided by 0.25. When you divide that, you have 6.67 times 10 to the power minus 9 Newton. This is the force. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.